This is a brand new V6 Arma Notorious, and this is a giant 2 kilowatt electric jet engine. And today we're gonna stick this on this, and we're gonna try to do it using only this. And if we can pull it off, we're gonna find out what 7 pounds of electric jet powered thrust does to an RC stunt truck. But before we mount up and probably destroy this large expensive EDF, I think it would be smart to try out a proof of concept with something just a little bit smaller and a lot cheaper. And what better thing to try it out on than our Speedrun low-C NASCAR? This should be interesting. As you can see, unlike on the larger system, this doesn't have any mounting tabs, which means we're gonna have a bit of a challenge getting it mounted up on this car. Now, obviously, the easy solution would just be to use a 3D printer, 3D print up the parts we need, but not only do I think those might not be strong enough, but I'm looking for a little bit more of a challenge than that, which is why we're gonna be using this, the new Makera Z1 affordable CNC machine. We're gonna be taking a closer look at this thing in a little bit, but first, what the heck even is an EDF? I'm not gonna bury the lead, this is not a true jet engine, but it is the closest electric version we can get. It uses what's known as a brushless outrunner motor here on the back, an outrunner meaning that the stator is on the inside and the rotor spins around it on the outside, and that spins this fan inside this housing. EDF stands for electric ducted fan, and other than the way that the fan is spun, this behaves very similarly to a modern high bypass gas turbine engine. That's why it looks just like something you'd see on a modern airliner. This big one looks even more like it, and that's because on a high bypass engine, meaning that there's a lot of air going around the actual gas turbine engine, most of the thrust comes from the gas turbine, or in this case, the electric motor, spinning a big fan in the front, moving a ton of air. On a modern high bypass gas turbine, there is some thrust coming from the engine itself as well, but primarily the thrust comes from the fan, which is why these work so similarly. Now, before we stick this EDF on this car, there's a couple things I need to do to the car itself. The primary one is to address the steering on it. In case you didn't watch that previous video, first of all, why not? It was awesome. But second, we had some serious steering issues at high speed, and I believe those issues were caused by this Endura servo and servo saver. After switching to them, the car was all over the place, and I kept having to recenter my steering after every single run. So I think we're gonna try to just switch back to the stock servo and stock servo saver. I'm not entirely sure this is actually gonna fix the problem, but it is the biggest change I made, and I found that when trying to diagnose problems, pointing the finger at myself and what I did is usually the best place to start. You guys gave me a ton of really awesome suggestions in the last video, and a bunch of you did mention that the servo could be a problem, and I just wanted to say thanks for all the help, and definitely keep those comments coming. And now, just to make sure this is actually working, let's load it up with a 4S battery, take it out, and do a quick speed run. The steering issues I was having were not subtle, so it should be pretty immediately obvious if we've made it better, and I can tell you already, it feels a lot more stable. Let's give it a little bit of speed. Yeah, that feels so much better. I can't tell you how much trouble I was having with the steering before, and now it feels pretty much rock solid. So I really do think a lot of our problem with the speed runs before was something to do with that aftermarket steering. This feels so much better. It's very planted, very stable, and I think we're gonna have a lot better luck today. All right, guys, yeah, even on that rough road, that felt a lot more stable, so I think we can go ahead and move forward with making it probably a lot more unstable. And we're gonna do that by mounting this EDF right on the hood. Is the hood the best place to mount it? I have no idea, but I think it looks the coolest on the hood, so that's where we're going with it. Again, this is just a proof of concept anyway before we risk destroying this much larger, much more powerful EDF. So to slap it on here, I'm just gonna come up with a very simple mount. First of all, I'm just gonna take the diameter of the housing, which is about 54 millimeter. We're gonna put that in CAD, create a little cradle for it with a flat on the bottom to mount to the hood, and then we're gonna cut it out of this epoxy tooling block on the new Makera Z1. This is pretty straightforward. It comes almost ready to go out of the box. I do wanna mention this is a prototype, and whereas this does feel like a final version product, there are definitely gonna be some changes before the final product actually comes out. This thing's designed to be a much more affordable alternative to things like the Carvera and the Carvera Air. It has a smaller build platform, and while the spindle still has the quick release that we got on the Carvera Air, it's a slightly less powerful spindle. It's also running lead screws instead of ball screws. Let me show you the difference between those. The motion of everything on the Carvera and the Carvera Air are controlled by ball screws. Basically, it's this threaded rod that spins and moves this nut back and forth as it spins. However, this nut is very special, and there are ball bearings that recirculate inside it, and those ball bearings run in these grooves, which allows the system to have very little of what's known as backlash. Backlash is essentially the play between parts that move together, and every system needs a little bit of backlash, but these ball screws require a lot less than something like this lead screw and lead screw nut, which is basically just a screw and a nut. Looking closely, you can see there is some wiggle room between this lead screw and this lead screw nut, and it's a lead screw feature like this that's used on the Makera Z1, that's not necessarily the end of the world because there are anti-backlash systems for these, and the Z1 appears to be using them because it feels very stiff, and stiffness is the name of the game when you're doing machining. Assisting with that stiffness is this massive chunk of aluminum frame. This is all one piece, and it's a lot better than chunks that are bolted or welded together. All of the axes also run on linear rails, which is a really nice feature. And again, this whole thing does feel very stiff. Controlling that motion on the Z1 are stepper motors, which are very similar to this. They're basically like RC servos, but they have no positional feedback, and this is very similar to what's used on most 3D printers. These work really, really well. The only problem is if they end up losing steps, meaning they lose track of where they are, they don't know it, so you can end up having problems with your parts that you wouldn't have with a servo motor driven machine. Again, we'll have to see if that's actually a problem in practice. But we're here to stick electric jet engines on RC cars, so let's get to machining. I've got this block mounted up in the lower left-hand corner of the bed. This is the zero origin reference, and it matches the zero origin reference in the model I made and in the cam that we're going to use to actually do the machining. There are multiple different options for cam. Carvera has their own cam software, and cam stands for computer-aided manufacturing. It's basically what takes the model and tells the machine how to make it out of something real. I'm gonna go ahead and use Fusion 360 cam for this because it's what I know, and they have Fusion 360 profiles for all their machines. With this all set up and simulated, we can go ahead and cut it out. And to keep the mess down while we did it, we use this, the new Makera Cyclone Dust Collector. It combines a cyclonic separator, which you see here, which dumps most of the big debris down into a catch bucket on the bottom, and a big HEPA filter underneath this top cover, which has several different elements, including an activated charcoal section to keep smell down when you're using the optional laser engraver. And while the Z1 doesn't have a dedicated dust chute like the Carveras do, it does have a port in the back that draws most of the debris through. So I might be a little bit concerned about using this for carbon fiber, as I suspect a lot of carbon fiber dust would still end up in the machine, so that's something to be aware of. And with that done, you can see we got a perfectly smooth finish here on this inside part. Ignore this side, I actually ended up having to cut this off with a hacksaw. That was a programmatical issue on my end, not a problem with the CNC machine. And then this also fits perfectly in the ducted fan. I left a little extra room for some double-sided tape, because that's how we're gonna temporarily mount it up to this car. Of course, we're gonna have to make a much more serious mount for this big EDF, but I think this will work just for proof of concept testing. We'll put a single strip of VHB right here on the housing of the EDF, and with the backing removed, we'll push it down into the block. I was a little concerned about how well this would stick, but that's not going anywhere. And sitting on the body, that looks pretty mean, but before we mount that up, we've got a little bit of wiring we need to take care of, because just like the traction motor, this thing actually needs its own ESC. This one came with one. It's a 40 amp, takes 2 to 6S, and it hooks up exactly the same as a regular ESC does. However, to avoid damaging anything, we need to remove the power wire from it. This ESC does have a BEC in it, and you really don't want two BECs battling to try to power everything. That leaves just the ground and the signal wire, which will work just fine. And I'm gonna plug this into an unused channel on my receiver, which I can then control with this G11P. We've got a few options here. I can have it just go full throttle on a button. I can have it work off this slider here, or I can just slave it off of the throttle channel, which is probably what we're gonna end up doing here. In order to hook the motor up, the wires are gonna have to pass through the hood. And so I don't damage this any further, I think we're gonna switch over to our beater body, which I don't really mind messing up. To punch the hole, we're gonna use this specific RC car body reamer. This is designed to punch clean holes in polycarbonate, and it works really, really well because it doesn't risk cracking the body like a drill bit might. You can see that leaves a beautiful clean hole, and if you're doing any RC car body work, a reamer is a great thing to get. And now we can just stick this thing on the hood. For our first test, I want to see what just the EDF can do, so we're going to go ahead and remove this motor entirely. Of course, that means we're also not going to have that motor for brakes, but fortunately the ESC for the EDF does allow us to do reverse thrust, so we'll have it for braking. That should be really interesting. And with the ESC program, this thing is ready to go. Let's go see what it can do. Well, the thing looks really awesome, but unfortunately, brake did not mean what I thought it did, and it just stops the propeller. It's not actually reverse thrust, so I'm not gonna have any brakes, but let's see if this thing will even move, and I've got some ideas. And yeah, even at low throttle, it does seem to be moving. I do have to be careful because, like I said, I can't actually stop this thing now. It's just gonna have to coast to a stop. So let's see if we can get a little bit of a pass going here and see how it is. Okay, well, it does seem to have enough power to move itself, though it's not the most stable thing in the world. It's also pretty breezy out here. Let's try that again and see if we can keep it straight. All right, here we go. It sounds pretty cool. Oh, yeah, no brakes, no brakes, no brakes. Okay, yeah, we need to figure out some brakes for this thing. Let's bring it in and fix that problem.
It does seem really cool though.
Okay, so this obviously has potential, but not having any brakes isn't gonna work. And I realized that we could just use the Castle ESC since we're not using it for the traction motor. Some flight ESCs do have reverse thrust, but I guess most airplanes don't use it, so this one doesn't have the option. And of course, now thinking about it, it makes sense that brake wouldn't actually be reverse. These wires are pretty short, so I'm gonna go ahead and hook them up off camera, and let's go see what this Castle ESC does with this EDF.
All right, let's see if that works any better. We've got throttle and brake, and it'll even go into reverse. All right, that makes me feel a lot better. Let's see if this thing is actually gonna work now that I feel more confident that I can stop it when I need to. Yeah, brakes do work. All right, here we go. Yeah, that actually does work. I mean, it's not the fastest thing in the world, but as a basic first proof of concept, I think this is a complete success. And it sounds really cool too. Oh, don't hit the bump. The brakes don't really work all that well, but it does slow down better than not having any at all. Let's get one close pass here. It sure sounds cool. All right, let me bring this in, and I think we need to take this to the next step.
Okay, I'm convinced. I'm not sure if we're gonna be setting any kind of record or if there's even any record to set with this type of setup. But that little 50mm EDF is pretty rowdy. And if nothing else, it's getting me really excited to try out its 90mm big brother. And we'll just pop this motor back in here. I'm gonna reinstall the EDF electronics, and then let's take this monster to the going fast spot.
I have to say, I genuinely have no idea how this is gonna behave. I've got the EDF and the regular throttle on the same trigger, so they work in unison with each other. I'm gonna start off with a little bit of an easy pass and bring it up from there. Hopefully we don't destroy this thing on the first pass. All right, here we go. Well, it sounds really interesting. Okay, that was actually more stable than I thought it was gonna be. Let's go ahead and go for a speed pass. I suspect if this thing crashes, it's going to destroy the EDF pretty much immediately. So that's just a risk we're gonna take. I wanna see what kind of speed we can get out of it, so let's give it a try. Don't think we're gonna be breaking any records here, but here we go. Well, it definitely sounds awesome. Oh man, that was actually a lot more stable than I thought it was gonna be. I think we might be running out of jam on the battery though, running both these systems at the same time. Let's see what we got. All right, that was 65 miles an hour. And keep in mind, this is only on 4S. This whole system can do 6S. So let's give it one more try. See if we can get a little bit over 65. Oh, it sounds so mean, and it's so much more stable than it was with that other servo and servo saver. Let's check it out. And yeah, 65 miles an hour is all we're gonna get.
That went a lot more smoothly than I thought it was going to. I honestly expected the EDF to make this really unstable, and I think it actually made it more stable. I only put this on 4S because I expected it to pretty much crash immediately and get destroyed, but maybe we're gonna have to try 6S later because I think this might have real potential. I think we can say the concept is well and truly proven, and now it's time to get serious. This EDF is only about twice as large in diameter, but it's several times more powerful. The specifications say it can produce 3.2 kilograms of thrust. In Imperial, that's about 1/100th of a baby hippopotamus, and I don't think our old mounting system's gonna work. I'm not sure I believe that thrust specification, and to figure out what kind of mount we need, let's find out what its thrust really is. To do that, I bought these linear rails and this fish scale, and we're gonna build a slide that'll tell us exactly how much this is pulling at full throttle. These linear rails are very similar to what guide the axes on the Z1. If you look closely in here, you can see there are recirculating balls in these guides, and those balls run in tracks on these rails, and these rails are very stiff and very strong. Now, before we use all these parts to see just how powerful this giant EDF is, I want to talk to you a little bit more about the Z1 and why I think it's so special. The Z1 is a CNC mill. A mill basically does the opposite of what a 3D printer does. A 3D printer builds up material to make your part. A mill uses cutting bits to remove material to make your part. Both have their advantages and disadvantages, but a mill can work in things like metal, and whereas you can technically do the same thing with a 3D printer, it's very, very expensive. There are a lot of CNC mills available like the Carvera and Carvera Air, but the beauty of the Z1 is how small it is, how compact it is, and its affordability. At 14 inches wide, 19 inches deep, and 18 inches high, or 34 inches high with the lid open, it's able to fit in a lot of places that larger CNC machines simply wouldn't. The working area is about 8 inches by 8 inches, which is pretty decent for the external dimensions. But of course, there are plenty of options for small CNC machines out there. I think what you're paying for with this is the features you get. It's fully enclosed, meaning you're not going to be throwing chips all over the place when you're using it. It has a chip evacuation system that you can use with the Makera vacuum, or you can use your own vacuum if you want. Just make sure you have good dust filtration in that vacuum so you're not blowing dust all over your shop. The quick change bit system is a game changer. While it's not quite as convenient as a full automatic tool changer like you get on the regular Carvera, it makes changing cutting bits very, very fast. And the little button back here is an automatic tool setter, which means it will detect the length of the tool every time you put one in, meaning you don't have to do that manually. To go along with that is this manually installed automatic probe. This will go and detect the top surface of whatever it is you're cutting, meaning you also don't have to set that up manually. And it will also detect the surface in a grid, so if you're doing really fine work on something that isn't perfectly level, it can accommodate for that. The aluminum bed, which runs on linear rails and uses lead screws, is topped by this MDF spoil board. Because a lot of times you'll be cutting through whatever you're cutting, this spoil board acts as a sacrificial piece so you don't cut into your main bed. The machine also comes with a couple of hold down clamps that you can use for holding down your work, though there are a ton of other clamp options you can get from Makera and elsewhere. And all these hardware features combined make milling a lot easier than it would be with some other options. The other thing that's really going to be helpful, especially for newcomers, is the software, which we're going to talk about in a few minutes. But for now, I think it's time to see just how powerful this giant electric jet engine really is. Of course, this test rig is going to be very temporary, so we're going to start with something really simple and see if that works. I've just got this piece of plywood here. We're going to mount the motor to the front, and then to mount the EDF to the linear rails, we're going to need some kind of adapter. I think that's going to be the perfect thing to cut out of this really nice sheet of brass. This will give us our first taste of the metal cutting capability of that 150 watt spindle. And of course, being brass, it's going to end up looking cool. This piece will be very simple. We're just going to take a couple of measurements on the bolt hole pattern for the linear guide, some measurements on the EDF, which we're going to need later anyway. Then I'll just transfer those measurements over into CAD, make the adapter plate, set up some pretty easy cam for it. We will need a smaller bit for drilling the small holes, but that's not a problem. Once we've actually sent the cut information to the machine, I'll show you the program for that later. You can see we have a light blue blinking light here that's telling us to put the probe in. Once we have that in, it's going to go ahead and automatically calibrate the probe. Use a laser in the end of the probe to show us the outline of the work area. This lets us ensure we're going to be cutting exactly where we want to be cutting. Then it's going to probe the top surface of the material to get its 0 reference. Move the cutting head back home, and now you can see it's asking for tool number 4, 3 blinks and 1 blink, which we can go ahead and insert now just by pulling the lever down, pulling the probe out, putting the tool in, and letting the lever up. It's going to start the cut, so we need to close the lid, hit this button, and off it goes. While it's drilling the holes, you can see a combination of the fan in the head and the vacuum in the back does a pretty decent job of managing the chips. I found it does a really good job with materials like metal that don't tend to stick everywhere, and a little bit worse with things like plastic that have a little bit more static cling, but overall it does work fairly well. And it is nice not to have to deal with a dust shoe, which can cause problems in deeper cuts. And just about 3 minutes later, you can see we have a nice brass adapter. The holes line up perfectly on the rail, and they line up perfectly on the EDF. Now, whereas this adapter could be 3D printed, something this thin isn't going to be very strong no matter what plastic you print it in, and being able to cut it out of brass or aluminum is really nice. And with those mounted up, we can start to see the vision of how this test stand is going to work. These rails will be mounted down to the base plate, and the motor will be free to move in them. We'll have the fish scale somehow connected to the back of it, and when it's at full throttle, we'll get to see how much thrust it makes on this screen. Due to the inherent over-constrained nature of a dual linear rail setup, I found it necessary to inbuild some compliance to the system. In other words, I misaligned these rails, so I've only got one screw on this side so it can wiggle back and forth. Okay, we've got everything hooked up. I've got the actual scale tied to a concrete block back here, so it's not dependent on the board. I've got my most powerful 6S battery. Let's see what we get out of this thing. All right, that was 3 kilograms, but it was trying to push itself over, so let me put my foot on it, and let's try that again. Okay, so this thing actually has 4 kilograms of thrust, which is significantly more than it says it does. And holy crap, does this thing put out a lot of air. I'm actually really glad I did that. I was expecting this thing to be less powerful than its specification, and it turned out to be quite a bit more powerful, which means I'm gonna have to mount this thing more securely than I was anticipating. If I didn't mention it before, the goal of this is to see if we can make this truck go faster and, more importantly, jump higher. I want to launch this truck off a ramp, fire this EDF up, and see if it'll go straight up. And if you enjoy these kinds of crazy antics, make sure you hit that subscribe button because we've got a lot of really interesting things coming in the future, and I don't think you're going to want to miss them. My biggest concern for mounting this up is going to be its durability. This thing's going to be sticking up above the truck, and I'm pretty sure if we land upside down, it's probably going to end up getting broken. To make its mounting as strong as possible, I think we're going to use this piece of Delrin. This should allow us to have a nice long base here where it mounts to the bottom of the body. And then I also think I'm going to carve a Delrin fin out so it actually protects the top of this in an upside down crash. Because we previously made these plates, I've already got the hole measurements for the EDF itself. So I just need to take some mounting height measurements and some measurements of the room we have on the underside, transfer all that into CAD. I'm going to create a mount that's wider on the bottom so we've got more purchase on the Lexan body. Then we're going to go ahead and mount the Delrin up, cut it out. This is going to be a two-part process. Once the outline is finished, I'm going to put it up on end, and then we're going to drill the holes in the top using a different model and cam setup, which gives us a great opportunity to talk about the software that comes with this Z1, because I think this is where the biggest advantage comes over other options. Not only does it come with its own cam software that has all the profiles for the bits that you're going to need to get started, as well as the ability to program fourth axis machining using this optional fourth axis. This thing's pretty cool. It allows you to have a rotary axis as well as your X, Y, and Z axes, and it lets you machine things you really couldn't do otherwise. But with the Z1, Makera is introducing something called Makerables. This is going to be fairly similar to what Thingiverse is for 3D printing, but for CNC machining. This is still very much in beta, but there are a bunch of projects on here you can click on. They'll give you the files you need to actually make the cuts, as well as tell you what materials you need and how you need to set them up. This is going to be fantastic for people who have never done CNC machining before, as there's a pretty serious barrier to entry and learning curve when you start CNC machining, and this is going to let people do projects, get parts in their hands, and get excited about doing it, as opposed to just being frustrated as they try to learn CAM. And I think it's going to make the whole process of learning to use these machines and learning CAM a lot more fun and interesting. By the way, along with this fourth axis, you also have the option to get a 5-watt laser. This thing's pretty sweet. It just mounts right up to the spindle and allows you to laser engrave on your CNC machine parts without having to reset everything in a separate laser cutter. And now finally, after about 15 minutes of machining, we have our mounts. These things look really, really nice. The finish is pretty consistent. We've got our holes drilled in the top, and they align perfectly with the mounts on the EDF. Again, whereas you could 3D print something like this, I don't think it would be as strong as this solid chunk of Delrin. And one thing I wanted to show is how sharp of an edge you can get when you CNC machine. That's definitely not something you can do easily with 3D printing. The last thing we need to do before mounting this up is one thing you definitely can't do with 3D printing, and that's cut some braces out of this sheet of aluminum. These are going to go on the underside of the body and extend underneath this center support, and that's really going to help prevent the screws from ripping through this Lexan. Just like with everything else, I'm going to whip these models up quickly in CAD. This is not a very complicated design. Then we're going to go over to the Z1, and I'm going to use the exact same settings I used on my Carvera and my Carvera Air, watching and listening to this cut. In spite of the fact that this thing has lead screws instead of ball screws and has a less powerful spindle, I can tell it's having no problem cutting this aluminum using those exact same settings. And looking at the final product, we can see it did a really good job of making the holes and cutting the outline. There's a little bit of inconsistency here where the tabs were, but that's mostly visual. You really can't feel it with your finger. And overall, I have to say I'm very impressed with how it handled aluminum, and it really makes me want to try some steel. I've just got a very simple program. We're going to do a 10mm box with a 20mm box around it. Not only will this give us an idea of how it cuts steel, but it's going to give us an idea of the accuracy of the machine when it's cutting a big, strong material like this. Right now, it's only cutting at a 0.1mm depth of cut, and it's cutting pretty slowly, and the machine doesn't seem super happy about it, but it is doing it. And this is the final result here. It looks very, very clean. I don't see evidence of a lot of chatter. The walls are nice. The floor is nice. Checking the dimensions, this inner box should be nominally 10mm, and it is 10.07mm, which means it's 7/100ths of a millimeter off, or about 2/1000ths. This external box should be about 20mm, and it is 19.98mm, which is only 2/100ths of a millimeter off, or around 1/1000th. For a home gamer hobby machine, that's plenty accurate enough, and I'm really impressed with it. While it was running off camera, I went ahead and put the mounts on the EDF. You might think these mounts are backwards because the EDF pulls forward, but that's not really what I'm concerned with. The front of the EDF will basically be resting on the bed, and that's going to provide extra support for acceleration. My big concern is the whole thing getting ripped off backwards if we hit something upside down, which is almost certainly going to happen. This fin that's going to go on the roof should help mitigate that somewhat, and then these aluminum reinforcement brackets going underneath the structure here in the middle is going to help as well. Even with that protection though, I suspect this is probably going to get ripped off or damaged on its first upside down landing, which is probably gonna happen when we bash it. Of course, before we bash it, I wanna speedrun it, and before we speedrun it, I wanna get a baseline with the stock truck.
So now we got a fresh 6S battery loaded up. Let's get this thing down there and see what it can do. Sometimes these trucks can be wheelie limited, but sometimes they'll keep the nose down. Let's see what we get this time. We've got full throttle. She's trying to pick the nose up. Stayed nice and stable though. Let's get one more pass out of that. This thing feels pretty stable on solid surface. Full throttle. Yeah, pretty good. Not bad for a stunt truck. Let's see what we got. I suspect it's going to be around 45 to 55 miles an hour, and we got 50 miles an hour. That is a great start. Let's see if we can do better.
And of course, the first step to that's actually getting the EDF mounted up, just like that, and with those braces on the bottom, this actually feels really solid. I'm having high hopes it's not going to get ripped off, and I installed the fin to hopefully prevent it from getting ripped off when we end up upside down. I know some of you guys are thinking that the cab's going to be blocking airflow to the fan. I personally don't think that's going to be a problem, but again, there's only one way to find out.
All right, just like on the NASCAR, I've got both throttles tied together, so they're running 1-to-1 with each other. I've got the biggest drag racing 6S battery I have in here. Hopefully it can handle the power from both of these. Let's see if we can do more than 50 miles an hour. Here we go. Whoa, okay, it wants to wheelie. I'm actually surprised. I figured having the motor up there with all the air pushing down from the top would stop it from wheeling, but it seems to want to wheelie even more. It must be the extra weight in the back. It certainly is louder. Let's try one more pass. I'm not getting anywhere near full throttle, unfortunately. All right, one more time. Here we go. See if we can get full speed here. I guess as good as we're gonna do. Let's see what we got out of it. This thing certainly is a handful. There we go, guys, 59 miles an hour. That's almost 10 miles an hour more than without the EDF on it, and it definitely has more to go if it wasn't trying to wheelie the whole time. All right, now I've got the EDF just on a separate button, so it goes to 100% as soon as I hit it. Let's see if that's gonna help us jump. I got a lot to focus on here, so hopefully I can actually get all this stuff coordinated at the same time. We're gonna go for a little jump at first. Okay, it pushed the nose down, and this is gonna be a lot harder than I thought. Let's go for something a little bit higher, so I've got a little bit more time to think while it's in the air. Oh God. Oh man, I do not know how long this EDF's gonna last. This is complicated. It's really hard to think to push another button on top of everything else I'm used to doing. Oh! Okay, it's pushing the nose straight into the ground. So far, everything's holding up though. I'm kind of surprised. Might need to give it some more throttle as I hit the EDF to keep the nose up. Let's try that. Oh God! Didn't quite get the button hit that time. All right, let's see if we can get this coordinated. Oh man, it really wants to put the nose down. I am pleasantly surprised we haven't killed the EDF yet. Let me try hitting it before we leave the ramp. Oh yeah, that worked. We got extra air that time. All right, that gives me hope, but man, is it complicated. The EDF really wants to push the nose down, but it definitely stayed up in the air that time. Let's try again. Yes! Oh, I think we broke it. Nope, that was just the fin coming off. The EDF itself is surprisingly durable. Here we go again. Oh! Okay, I actually don't think I have enough rotational inertia, even at full throttle, to counteract the down push from the EDF. Let's find out. I'm gonna go full throttle on this one. Oh no, it does. And is the EDF still working? Nope. It's broken.
That actually went a lot better than I thought it was going to. It turns out that the EDF itself isn't even broken. The ESC it connected to, however, is broken. Turns out those ESCs are not designed to get slammed into the ground over and over. I will say though that this shows a lot of promise. I got a lot more airtime on a couple of jumps than I thought I was going to, and I'm not sure how well it showed up in the video, but this is pretty cool. With that being said, it's also insanely hard to control, so I need some more practice with this before I can really get that serious airtime. Now, hopefully not speaking of serious airtime, it's time to try this thing out on 6S, but before before we do, I want to talk about my opinion on the Z1. In the time since I started making this video, the Z1 Kickstarter went live, and now they have over $5 million in backers. I'm not surprised about that because this thing is a very capable machine, and it's reasonably affordable. Obviously, backing a Kickstarter is always going to be a risk, but given that Makera has produced 2 previous CNC machines, I would say this is more of a pre-sale than a Kickstarter. And given that this prototype Z1 seems to be already pretty much production ready, I suspect if you back this, you're going to get what you order. This is a Kickstarter though, so there's always risk associated with that. With that being said, for the price and the features you get and the ability to cut steel if you really need to, I think it's a heck of a deal for the home gamer. All right, enough about that. Let's go see what this thing can do on 6S.
Let's see if we can beat that 65 miles an hour, and who knows, maybe even the fastest I did on the other video, which was 78 miles an hour off camera or 72 miles an hour on camera. Not sure we're going to be able to do it, but it's definitely worth a try. Here we go. Whoa! Okay, all right, a little bit of a wipeout there. Let's see if we got any damage, and let's see how fast we went. All right, that was 67 miles an hour, and everything looks good, so let's give it another try. Gonna have to be really easy on the throttle. Between 4S and 6S is a massive difference, and I'm having a lot of trouble controlling it at those higher power levels. It really just loses traction and then takes off. Here we go. Nope. Oh, incredibly, after that hit, it's still going. I am really surprised. The steering is definitely fixed from what it was before. I went ahead and added more steering expo, and let's see if we can keep it under control a little bit better this time. All right, here we go, guys. Nah, it just wipes out above a certain speed. I think the EDF's actually harming it at the higher speeds because it just spun out there and I wasn't really out of control. We're gonna give it one more try, but I think the EDF definitely is causing problems at high speed. All right, last try, guys. Here we go. Yeah, it just wipes out above a certain speed, so we're not going to get over that 67 miles an hour, but you know what? It was worth a try.
Okay, so electric jets on RC cars, what do I think? I think they've got a ton of promise. I had a bunch of fun with both of these setups. I'm shocked at how durable these things are. Both of them took some serious hits, and both of them are fine. And checking my GPS, it turns out I actually managed to hit 73 with this at some point in that testing. This kind of experimentation is always risky because you never really know how it's going to work out, but in this case, I think it was a lot of fun. And if you've never messed around with an EDF before, I'd recommend picking one up and just giving it a try. This little 50mm guy here really wasn't very expensive, even with the ESC, and taking one of these and slapping it on a Mini could be a lot of fun. Subscribing to this channel is also a lot of fun, and these videos are a lot of fun.